Okay, so today we will start our short session about state diagram representation. So you have already known to this because in your digital electronic class you have already used this state diagram to represent the states of the counter, and here we have also used two delays. You can say from this diagram that this is S1 and this is S2. This is two delays, or you can say this is two registers and flip-flops, whatever you can say. And we have to just make this table. This table, you can see that this table. Okay, to just represent the state of S1 and S2. So this is MJ. MJ, as I've told you, that J instant, at J instant the input information bit is fed to the encoder, and we're getting corresponding C1J and C2J at J instant. So these are basically the encoded output bit. Okay, so in the previous lecture we have seen that how to calculate C1J and C2J, and that was a hectic process. So when we follow this table, when we follow the state diagram table, so it will be easier than before. Okay, so just let me erase it, and we will start discussing about this table, how to make it. Okay, so first of all you have to just, this is just written, you can follow that J is the present instant and J plus 1 is the next instant of time. That means this is, you can say, the present state as you have represented it in your digital class. This is the present state, and J plus 1 is the next instant of time, that means next state. Okay, S1 S2 is basically the delay, and this is MJ, present state, this is next state, and corresponding C1J and C2J. So as you know that this encoder is basically nothing but the right shift register. Okay, when we feed any bit to the M, that means message input, so when we, so it will generate the C1J and C2J correspondingly, but when we feed this M with new value at the next stage, then the previous value of M, will be shifted right to S1, and what was present in the S1, that will be shifted right to S2. Okay, so that's why this is called the right shift register. So this is nothing but the right shift register. So in this way we have to follow this table. Okay, so here in this table you can see that MJ is basically the message input bit and J instant. This is the present state of what? Present state of S1 and S2, and this is the next state. Okay, this is the present state, this is the next state. So you have to just draw this table like this. First of all, you have to write MJ, then present state of S1 and S2, next state of S1 and S2, and this is C1J and C2J. This is the corresponding output, right? Okay, so first we are assuming that MJ, that means the message bit at J instant, is basically 1. So I'm just assuming it that 1. You can assume 0 also. So this is 1. If this is 1, then present state is 0, 0. 0, 0. Why 0, 0? Because I'm assuming that S1 and S2, these two delays are basically in the reset mode. Okay, so this is basically in the reset mode. So that's why this is, the present condition is 0, 0. So S1 and S2 is now 0, 0. So what will be C1J and C2J? So if we follow, just let me use this. Okay, so if we follow this, how this C1J we can get? So C1J equals to MJ XOR with S2, right? That means MJ XOR with this, that means S2, right? So C1J is basically M XOR with S2, and C2J is MJ, S1 and S2. Okay, this three component, and this three component is going to the XOR addition, and we are getting C2J. So in this way we can generate this C1J and C2J in this table. So when MJ equals to 1, and present state we are assuming as S1 and S2 in the reset mode, so this is 0, 0. So C1J will be M XOR with S2. So M XOR with S2. That means 1 0 1, and C2 will be the XOR of 3 elements, that is 1 0 1 and 1 0 also 1. So we are getting this is 1 1, right? Now the next step, what will be the next step? So before going to the next step, we have to, I'm just assuming that I'm feeding this encoder with new value of message bit in the next stage, which is 0. Okay, when 0 is being fed to the encoder, then the previous bit, that means this one that was present, that is basically the previous value of the m. So that one is basically going to S1. So this is right shift, and what was present at the S1, the value of the S1 was 0, and that 0 will be shifted to S2, right? So when m will be shifted to S1, so 1 will be shifted to, that 1 is shifted to S1. Okay, now what was present at the S1, that was 0, the present state of S1 was 0, that will be shifted to S2, right? So in this way we have to generate the next step of the delays. I'm just repeating again. The first value of M1 MJ was 1, okay, and we were assuming that S1 and S2 in the reset mode, so that's why the value of S1 S2 was 0 0. So how we can get the C1J? C1J is basically M XOR with S2, okay. So M is 1, S2 is 0, so 1 0 is 1, and as well as C2J is the XOR of 3 elements, so 1 0 is 1 and 1 0 is again 1, so 1 1. We are getting this is 1 1. So our intention that how to get the next step. So when I'm feeding this encoder with new message bit in the next stage, which is 0, then the previous bit will be shifted right to the S1, and what was present at the S1, that will be shifted right to the S2, okay, in this way. So that is my next step, okay, and that next step in the first row, will be the present state of the second row when I'm feeding new bit at message. So 0 0, when 0 0, then already this bits basically shifted to the S1 and S2. So now we can consider the state of the present state of the S1 S2 as 1 0. That means this 1 0 as 1 0. Okay. So now when I'm just getting this state as 1 0, so we can also generate C1J and C2J as before, like MJ XOR with S2, which will give us the C1J value. That means 0 0 is 0 0. Then what? C2J is basically the XOR of 3 elements. That means 0 XOR with 0 XOR with 1. So 0 XOR with 0, that means 0, and 0 XOR with 1, that is 1. So we are getting this is 1. Okay. Now again, what will be the next step? So before going to the next step, we are just assuming that we are initializing this message bit as 1. Okay, we are feeding this encoder as 1 1 1. So when 1 is present in the message bit, then the previous 0, this 0 will be shifted to S1, right? This 0, that means M is shifted to S1, and that was present in the S1. What was present? The value of the S1 in the previous value was 1. So that will be shifted to S2. Okay. So this is basically the right shift. So in this way, we are getting the next state of the encoder, which is 0 and 1. And that 0 and will be the present state when a new value is fed to the encoder. So that is 1. So when 1 is present, so 0 1 is the present state, and as well as we can get C1J and C2J. So what is the C1J? C1J is basically the message bit XOR with S2. So 1 1 is 0, and